sharp at 8:30, so that latest by 9:30 we reach there, and try to carry sunscreen and sunglasses and caps or hats, because it can be quite scorching because it's a very rocky area. So just walking around for 1.5 hours can actually dehydrate you a lot. So carrying water bottles, sunscreen and sunglasses and caps is advisable.
Typical archaeological looks.
Sorry?
Typical archaeology looks.
Well, they are not carrying whips like Indiana Jones. So, we will be having lunch, hopefully. So there's a beach right next to Tiger Cave. So our plan is to actually have a picnic lunch. So we'll be having food carried in a vehicle, like, closer to lunchtime. So after seeing all this, we'll be having a kind of picnic lunch on the spot. We'll find which place has lots of shade, and they'll be setting up base and they'll be serving from there. Okay? And then after lunch, we'll get back. So, which will give us plenty of time to people who have flights around maybe 5 or something, or trains around that, to get to the station or airport in time. All right. So then, without further ado, let me invite Ashraf to give his talk on segmentation of inscriptions across languages.
Thank you. So, okay, welcome back. Okay, as he said that we are going to talk on segmentation, which we call deciphering linguistic pattern. Okay, in his when I'm saying pattern meaning that, okay, in his talk he mentioned that our language or writing system has one essential is having one essential feature called syntax, and that syntax means recursive structure. That is my meaning here, the pattern meaning. Yeah, I'll explain all those things. So, I heard that, okay, from any question from yesterday's talk, because somebody was saying that, okay, someone has reproduced on Malayalam, right? Who did that? You. Okay. So he managed to do this. That's good. And you had some problem. He had some problem, right? You had some problem. Okay. So he didn't manage to code it properly. So I'll share my code. So anybody else did try? Okay, no problem. You can try any time. See, because see, our whole claim, even in the last talk, I had said that, okay, universal pattern, right? So it means that it should work in everywhere. So it's good that if you can come up with some language where it's not working, then we will see why it is. Either our method is wrong, or it is working. Really, it is universal. And again, we are claiming another term. Again, universal. So, see, why I said universal and why it's required. Okay, let me ask you one question. See, in a couple of days, you might attend many lectures in and around Indus Valley, right? So, what did you get it? Can you tell me few of the what is the common thing, common points every speaker said? Okay. What are the issues? Sorry? Brevity? Not knowing the language? Anything else? Yeah.
Don't have anything in for IVC.
No continuity. Shortness. Anything else? Sorry? Limited data, yes. Sorry?
not similar to any other script which.
Yeah, that is, yeah, no similarity. Sorry, yeah, no bilingual text, no Rosetta Stone. So, so these are the common thing everywhere, everybody said, right? Almost everyone. The whole target, even this, the purpose of this, more or less, the purpose of this whole workshop is also that, to bring up all kind of multidisciplinary people to come up with how to deal with these kind of situation, right? These are the reality, right? So since we know that we don't have enough data, we don't have continuity into the civilization, either in terms of language or any way, we don't have anything to correlate. There is no context. And on top of it, it's very small. So what can we do? And still we want to decipher it. We are working on it from decades and decades, right? So what is the way? What is the solution? One thing is that we can just start, we can keep doing guess, or we can do something else, little different. The only option, what we think that, okay, the comparative history will be the better option. It can be a good option. So that's why what we do normally, so it's kind of comparative history. So the ultimate goal, no doubt, somewhere the help in the decipherment, but since we know these are the limitations, these are the problems, the only option. So what we do, so already we, okay, we even during the talks we come up with that there is two school of thoughts. One group is saying these are the writing system, and these has this, and there is a group who are saying this is completely non-random, it's a random things. When we start working on it, we said, okay, from which side we should start, here or there? So the answer was that, okay, nowhere. Let's take a neutral path. Don't be linguist. Being a just completely computational student, what we can say, we can ask simple question. If it is random or linguistic, how can we do that? Just do the basic check. See, if I'll ask you to read all these, any of these lines, you can, anybody read, right? Anybody can read? Yes or no? Yes. If I'll ask you, can you read this? Answer? No. Answer, what will you happen? You cannot. Maybe it's not readable, right? Is that your answer? Am I right? Or somebody can read it? No, we can't read it. It simply means that whatever we are reading or writing, there is something okay, it means that whatever we are reading or writing, it has some pattern. It has some logic. What in a language we are saying grammar, but it has a pattern. What pattern it is? So if there is a pattern, then we can say that at least it has some similarity with linguistic things. If not, if it is a random thing, then we can say yes, it is random. So point is, can we, so what we said that, okay, let's ask simple question. If these writing system
So I have a question
Yeah.
actually regarding the pattern.
Yeah.
That we are assuming that if we find a pattern, certain pattern, then it should tend to be a linguistic have a linguistic structure. But like it is very naive of me to think like here. But in non-linguistic religious motifs, we also find a pattern. So how
That's
will
true.
we?
Very, very, very true. See, what I said, first thing is, I said there is two school of thought. There is one saying that these are the linguistic system. There is saying that some random text. Let's first do that. Can we say this is random? If it is, what we can check, whether it is random or not, that we can check very small basic statistics, right? That will just say that whether it is a random or not. It is not going to say whether it is a linguistic or not, right? So that question we can ask at least, right? That is the whole thing. So that we can start with an unbiased way. So for that, what we did, we asked simple things. Let's check it, whether there is any kind of recursive structure is available or not. See, how do we define recursive structure? It's recursive structure meaning what in biology we saying a motif, right? So the definition of motif is you have a string, whether your substring, the probability, joint probability of your substring is higher than your individual constituent, right? So let's is joint probability of AB if A, B. If it is purely random, the probability should be this, right? If it is much higher than this, then at least we can say that this is not just because of random chance. What Professor Sinha was showing you the tossed coin, right? He took two coin and said that what is the probability of both will come head. If it is independent, what should be the probability? Half into half, right? If it is more than that, if it is biased, it will be different. So that is, so this is the simple definition. So it's easiest way to just check it, whether any substring, you have a text, a small text, just check it, any substring is showing this property or not. If then we can say at least it has some recursive structure. Okay, how you can interpret it? Just later, that's a different matter. So at least we can check that, right? So that we doing just by using z-score, simple, complete basic statistics. But ultimately by using z-score, what we trying to justify? This. That joint probability is higher than its random chance or not. This is the thing. So please ask question if any. I have a very small talk, so just you can ask me question. So what is the how we can do that? Just take an example that you have English text. Just think on the English text or whatever it is. You have a list of text. You have a dictionary text. What you can do, you can start with your database, whatever you're saying, you can say it's your dictionary. And now, if your target, let's say you want to check in a particular sequence, in this case maybe is a ball. Okay, so this is your sequence, is your ball, your target sequence, which you want to segment it. Okay, so it's but what I said here, compare with what? Compare with, this is random, right? With random chance. So I should have random data, right? Randomized data. Because what I want, because this one is already I know what is my empirical frequency of BA here. If I'll see, okay, I have a dictionary, I can check how many times that bigram appears in my dictionary. So that I have. So what I can do, I have to create this data. How can I create? What I'll do, I'll just check, I'll take the dictionary, go to each word and just shuffle the position. Just change the positions randomly. So it means that you are breaking the correlations, right? And now you have, and you do it many, many times. You can do it 1,000 times. So now you have 1,000 random ensembles. Correct. So now you are ready with, you had an empirical, so your target sequence is ready. Your randomized version is ready. Now you can just ask simple question. Okay, since so if it is my target is this, what I can do? If this is my target? What I can say? If this is the sequence, how many bigram is possible? Bigram is there in this particular sequence? Sorry, how many? Anybody? 3. Yeah, BA, AL, and LL. So I can say, okay, what is the empirical frequency of BA? What is the empirical frequency of AL? And what is the empirical frequency of LL? That I know from my things. And the same thing, what I can ask, I can look at my random data and I can check the same thing. I can check that, right? So once I have this, the empirical count and random count, and since I have a random data with 1,000 times, so what I can take, instead of taking one count, I can take, this is my empirical, so suppose it's X. So same thing, PAB of random, so let's say this is called random. So this is my X prime. So, and I can take the mean of it. So I have ready with it. So now I have a content of empirical count, random count, and this is just nothing called standardization. Just to normalize it, I can just use that. So just based on this, what I can do? I managed to calculate the how big this number is. Means that this probability, joint probability, how big this joint probability is. So I'll see that which one is high, which one is more far from the random. So if you'll see this, that I can say the z-score is 7, here is 29, here is 14. I can see immediately the AL, the joint probability of AL is much higher than this anyone else. So the step is just merge this one. Take this sequence and just merge into a new number. How will you do that? Just do this. So the advantage is, why I'm doing all these things, the advantage is you in this way, if you are going this way, you don't need to worry about the bigram, trigram statistics. Otherwise, there is a problem of you cannot compare with the bigram frequency with trigram frequency. So here, what I'm doing, I start with BL. So now I found this is my significant one, significant subsequence. So now I merge this. Now I'm saying B, and let's say this is one side, A, and now L. This is my new sequence. B, X1, L. Now I forget this one. Now my target is, how many bigrams here? This is one bigram, B, X1, X1, L. I'll calculate the same thing. Up to what time? I can go on. And then I can calculate, okay, I found that AL, actually not AL, X1L z-score is higher than BX1. So I merge that one. And keep going until you merge everything. So at the end, what will you have? You will have kind of this kind of map. Is a binary tree you will get. So once you will have binary tree, okay, corresponding each x1, you also had a score, you calculated z score, right? So that z score, let's say this, I just randomly kept given this, what? Let's say this b, if it is, please ask me, because I have divided my talk in two parts. One part is in theory, other part I'll just do the same hands-on. So maybe that time I will ask you to generate. So please, if you'll understand this time, so you can do it easily. B, A, L, L. First time I x1, it was I think 29, right? Something. I just randomly I'm putting it. Maybe x2 is, let's say, 10. And x3 maybe 1 or 2. You got it. You got that tree. Here is completely fine. If you want, now your target is how did you, how I have made this particular as a segment, why not this one? That I'm deciding the number, the score what I'm getting here. That is completely depends on you, what are based on the statistics. Any statistic is saying that, okay, z score, if z score is more than 3 sigma, you can say significant, because you are ensuring that, okay, 99% chance it is whatever you're saying is correct. It's not a by random chance. So what I have used, just, okay, if it is more than 3, I said that, okay, this part is, if it is here, if it is 3 or 4, or 3, more than 3, I could say that, okay, this whole part is my significant subsequence. If not, if suppose nothing is coming, then I would say that, okay, nothing is significant. Every individual identity is separate. So this is a method to create a segmentation. So that will automate the whole things. That will give you this kind of result. So if you will just see, if you will take any linguistic sequence, you can automatically manage to segment each linguistic text into meaningful chunk. And up to this time, I didn't use any language information, right? Did I? Did I? Please go. No, right? I simply said, okay, just frequency count, that's it, right? No syntax, no Hindi, English, anything, right? I just did based on a statistic. Now, whether it's a meaningful or not, now you have to check it. Now it's coming that, okay, what is the context? Information coming. So the point is, we can do this kind of thing. So up to here, any question? No. Okay. So what is this? So I tried to look at what are these. So at least I couldn't go all these because I was aware of English and Hindi. So I just tried to check it. What are these segment meaning? Can I try to find out? So what I found that almost you can say the 50% of this is somewhat affixes. Either affixes or root words. Right? Like ing is it's like that, or un is like, or root words. So, and similar with the Hindi and English both, almost. You can roughly say 50%. 50% what? We don't know. Maybe linguistic people can explain better. They can look at it, they can say what are these. But at least statistically what I can say, these are the I can say that, okay, these are the significant subsequent. I can say that, okay, in my, where I am, I can say it's a fundamental unit. So that may be a different term. So the point is, so that's what it is. So without using any linguistic information, I managed to segment into meaningful chunk. This is up to how we can interpret this. Okay. So what's next? Any questions so far? Please, no. So next point is, okay, did it. But again, we cannot compare with all the cases. Can we do some kind of quantification of this? Because still question is still same, right? What was our question? Question is whether any linguistic, these sequences have recursive structure or not, right? So how can we quantify this? For quantification, what I did, we found that, okay, see, while you are creating this table, so while you are joining it, ultimately what you are creating is a binary tree. The tree, the height of these are your leaf nodes, these each are your leaf nodes. From here to, okay, you can say height of the whole binary tree, you can count in this way. 1, 2, 3, 4, 5, 6, 7. Is the height is 7 here. The next one is you can to reach into the top, you can count here. 1, from here you can 1 step, 2 step, 3 step. Is there any confusion to count the? Can anybody volunteer? Understood the how to count this tree height? Can anybody say that what is the height of this this tree? Yes. Okay. Let me 1, 2, 3. 1, 2, 3. No, 4, right? Oh, sorry. You know, 1, 2, 3, 4, 5. Correct. The longest one. Correct. So yeah. So it means that you got it. So, but what here is 5. Here is something. So the point is, what is the definition of height? Is saying that if your sequence is random, the maximum height can be is n minus 1. Maximum height is n minus 1. N is your sequence length. The minimum sequence height, tree height will be log 2n. Your height can vary in these two range, these two extreme range. Either it is log n, n minus 1 or log n. So then we can check it. What is the height? So if you will do that, you can get this kind of tree for all the sequences. So you have one distribution here where your height is log of n. Here it is, I have L. Okay, L is length. So the log L or upper end is this. If you will see all the linguistic sequences, whatever we have tried, lying somewhere in between. Complete blank. So is it? I'm not able to. Maybe I'm not able to convince. Is it okay? Understood? Please ask question. Feel free because a talk is almost over. Yeah.
So are we saying that a real language, its tree height distribution would lie between log 2l and
Exactly.
L minus 1?
Yeah. In known log, because most all are known. Because what we don't, what is our target? We don't know what are other things. Let's work on these known things. At least we can interpret, right? We can understand. Like what I shown you that, okay, what are these tag? We could say easily, okay, these are the prefix, these are the suffix, these are infix or root words. So we can understood easily. So the point is, so the known system is lying between these two range. And these, if you'll see what are these are the random text. One is random, one is randomized. Okay, when I'm saying random, it's purely uniform distribution, taken from a uniform distribution. Randomized is just keeping the empirical frequencies same, just I distorted the close correlation, that's it.
Okay, so we do this on Indus to establish the fact that it is a real language. It is not randomized.
Okay.
It has a
Maybe I'll be killed. I'll say in this way. Indus is showing similar pattern.
So it's a supporting point.
At least it is not random, right? It has the behavior of Indus is similar to this. So it's nullify that whoever is saying this are random things, right? Yeah. No, I'm not taking, see, okay. Is each grapheme is a single unit. Whatever, see, Dr. Subramaniam gave you a talk that, okay, there are 4 people who has done the concordance, right? So each grapheme is a single unit. What is this unit? Okay, even in these things I have every possible, we have a logographic system also, logosyllabic, you can say that. So we have a syllabic system. Every kind of, in this method, you can use any kind of writing system. Irrespective of the writing system, language, you can use it. Okay.
No, my question was very, for example, for Indus, the average word length or the average symbol count is like 5 or something, and the largest one is
13, 14, yeah.
So in the analysis you have done, you are treating each of those symbols as a word, but so you're calling it a word, like in the, go to the next.
I am not saying that. Yes, I have taken along with that, because I don't know what it is, if it is a word, sentence, what it is. But yes, the other texts are words. Here I can say that, but that one I don't know. I have taken as it is. Hope. So, yeah. So.
I would have thought that you would say on the x-axis letter sequence length instead of word sequence length, or maybe a sequence length. I mean the word
maybe
word,
yeah, okay, yeah, okay, maybe, yeah, right. I'll say it's a sequence length. But yeah, since okay, I have taken all these words. Yes, that is true. So, that one Indus I'm not counting or saying. Anyway, even this particular figure is not establishing, proving that this is a word or sentence, whatever it is. Okay. So yeah, so this is what it is. So in this way we can, so this particular method, method is applicable for anywhere. You can use to get the recursive structure. Okay. So this particular thing is that once you done that, now you have a set of your recursive structure. Can you work on it? So these are, if you know, in English, you can say that these are very badly looking. Okay. Okay, fine. So these are the set of whole segments. Sorry. Yeah, recursive structure you have found. So the point is, what can we do? Can we go further deep down? Can we try to understand what are these and what are the behavior of these things? Because what is happening? Because what we have said, because what I said is, like example I have given, develop I think I managed to cut it this way. I don't know, like this, right? Maybe this way. So what I was saying, what is our method is saying, a word, whatever the string is made up of these units. If you will combine these unit, you will form the word formation will happen, right? So here, each in the network, each unit is my node, and side by side occurrence. Here is a devway and the lup is my there is a link. Okay, so that's how I have created the network. So once you will see the network, you can just easily some basic statistics are once you have a network, you can say, check the degree distribution. So once you will see the degree distribution, it's very interesting. Oops, okay, excess. Okay, fine. So possibly I have another one. Oh yeah, I have. So so just see this. Both are x-axis. This is cumulative distribution. You see, the plot is having the exponent is 1. And why, when we, and we tried, I think, on almost, in most of the cases, is very close to 1. And Sitabra explained what is this, right? When we saying power is 1, actually it's a negative 1 to the minus 1, so it's an inverse proportion, right? So, and when we checked in the same thing, in the frequency, it was exactly same, even better than that. So, what it implies? Anybody remember what was that? If the exponent is 1, what was, which laws he mentioned? Okay. Did he mention Zipf's things? Yeah, okay. So it's very famous, the Zipf's law. Okay, so where, okay, it's saying that Zipf's law is implementing that, okay, your small set of, okay, in Zipf's is saying mainly that small set of words, but in case of, okay, Zipf's has done in case of words frequency, okay. So where is mean that your small set of words is using higher and higher with higher frequency, and rest are almost not used. Principle of least effort, possibly, he also mentioned that. So the people have habit of using just few words again and again, and rest are not. So it's the ordered frequency, right? Okay, the first one, the frequency of the second one will be just half of the first one. It's like that. More or less, you can just do based on the what the exponent you are getting it. So, and what we found that this is, and we have, okay, not even this one is with IPS symbol of a same English text. And we just checked in all the languages, more or less same. So this is the another universal pattern we have found. It's saying that to form a word, for word formation, ultimately, irrespective of the language you're talking about, language system you're talking about, the word formation process is very same. It doesn't matter what is, what the people have used the same, same motif again and again in a similar manner, irrespective of the time. Because even here we have some ancient languages and different writing systems. So this is another universal pattern we have found. Right. So this is, and Zipf's was Zipf's was talking about the word level. Even here it is sub-word level. It's even in fundamental level. So somehow our the cognitive process is working in some way that, okay, even we were thinking some lower level, our word formation process is same. So, yeah. So we are using just a small set of things. So next, what else we can interpret from those kind of things, right? Yeah, sir.
Are we saying the
languages which are near to the log base log, which, that are more correlated. The letters are more correlated in that, and the languages which are near n-1, the letters are less correlated in that. So can
No, no, no. It's simply saying the frequency of uses. So it means how much. See, suppose if you have in your set the whole. Suppose the English case. Okay. See, you just managed to cut it into different segments. Your list of whole segments, suppose 1,000. You took a dictionary, 1,000 segment you have, right? So it means that the whole set of word, whatever you are making, trying to create in your daily life, you are creating from these 1,000 set, right? Right? Yeah. So in 1,000 words, maybe only 5. So for only 5 sequence, 5 segment, you are using again. Next 5, first one is with higher frequency. Next one is even little lower and little lower in this way. So top few are using with high frequency. Again and again. It means that most of the time you are using the same thing. Rest are just sometime you are using to like that. So you see frequency of uses is talking about that. So that is word level. So here is a word construction level. Zips told that the word level, what kind of your word using. I'm saying that even word construction level. Even in word construction, you are just using some kind of similar things. Like we know that we say ing, ing, ping, saying, it's like common pattern we are using, recurrent pattern. Right? That's what. Any other question? Yeah. So next, what we can analyze? Any guess? What we can see? So how many segments do we need to construct a word? Right. Yeah. Yep.
Set of words.
Yeah.
Now the ZIFs, in that we rank it by the word frequency, etc.
Yes.
Right? The slope, etc. is calculated
Correct.
based on that. Now here you have this individual words for say for English. Okay.
Yeah.
How many? So you have taken a set of words. What is the corpus number of words? It may be identical over all the corpus, right?
No, it's vary. Whatever I managed to get. So minimum, I think.
So for English, let us take.
English is around, okay, English I have used a little variable sizes. So I have minimum size, multiple databases, minimum 10,000 to maximum 60,000. But most of the rest of the databases are having around 10,000.
No, so I'm trying to understand how that curve, what are the different points?
No, okay, yeah, that's what. So that is not database size really matter. Here matters that, okay, what are the number of segment you are.
Yeah, so you may have kept the corpus size identical across the.
No, you don't require it, right?
So
even if you have, see, I took unique, let's say you took 10,000 seconds, right? How many, what's called, how many segment you manage to come up with your sequence? That's the count.
say for Hindi, what was the data size? Number of
Around 10,000 something.
Yeah, so for all the languages you had the same number of words? Or?
A few are varying. So mostly 10,000. Few, say like Indus is only 2,000.
Because the number of segments will depend on that, right? The more the number of words, the more the number of the segments, right? If unless the word size will be different, so we have to account somewhere for the word size as well as see if we are comparing two samples, two different things, and each has a different say if we are keeping same number of two letter words, 3 letter words, etc. Yeah. If we are comparing two things, exactly. So no. For the other languages we know. Only for Indus we don't know. No, but the unit which is taken for analysis is a word here. right?
Okay.
You have
Maybe, yeah, okay. Fortunately, maybe except one or two, all are 10,000. But even that is, even you can see in the degree case. Degree, we are independent of that, right?
what is this?
Degree distribution.
So then your degree of
Degree of your network.
and so the subsequences, the segments which you created.
Yeah, exactly. Where the node, your node is.
Yeah,
your,
then you're joining. Yeah, exactly.
Yeah.
So you're creating network
correct.
for that.
So it is independent of that, right? So yeah, so that's what it is. Yeah, maybe your point is very much correct. For in case of frequency, yes, it will affect. But since it is luckily okay, maybe Indus, English, rest. I don't think so. Rest are around 10,000. Two are differ. Yeah.
All right.
Yeah. So
I have one more question.
Yep.
So the minimum number of letters that we are considering in one word should be 3, because if we take
minimum, yeah,
minimum 3, right?
Yeah, minimum.
Okay.
Okay, I have used I think 2 or something.
Okay. But in case of 2,
That is not going to support anything.
okay,
Yeah,
so
that is-
it
yeah.
should be 3.
Yeah.
Okay, thank you.
Yep. So yeah, thank you. I think good point. Random and randomize, right? Yeah, random and randomize. So yeah. So yeah, so point is now once we have these segment, so this segment, so either how many segment you need or how many whatever I'm saying the fundamental unit you required to create one word. If you will see that in traditional method where you can see it can vary from, okay, this is just because of the distribution, somewhere 2 to 10 or something, 10, 20, it depends on the language you are talking about. So the variation is very high in tradition. Whatever, if you will talk about all alphabetical system, it needs lots of grapheme, right? In case of low graphic system, it needs just minimum few. But in this section, it's very much standardized. You just need around 3 units on an average. See, this is 2 or 2.5 or something. So 2 to 3. But here, the variation is very long. So the point is, to construct a word, you don't need, in every society, the process is same. There is uniformity. So this is a universal pattern that, okay, word construction process is same. So how, okay, what is the linguistic value? It need to work out, no doubt. Whether, see here it is, maybe it is very easy, we can say that this is a common suffix, but how can say lop? Because sometimes it's syllable also, I figure out, so I try to look at it, sometimes syllable, but sometimes 2 syllable together, right? Like I do remember Ashan, just if you take a nation, it's nation, so this is coming like this, Ashan. So have to work on this, what are this? But the uniformity is this somehow. So irrespective of, regardless of language you are talking about, the study is suggesting the word formation process of everywhere is common. Any questions so far? No. Good. So the conclusion is, we can say that this is a robust method of segmentation, which you can apply anywhere, any kind of things. It depends, but the method is quite robust. If you will use here in the linguistics, in this kind of scenario, it also is showing that your segments, your whatever the significant subsequence, showing the Zipf's law, which is saying that okay, the uses of those segments are much organized way. What is the organized way? Commonly, the few are commonly used and rest are just negligible. Yeah. Rest, this third one is the number of recurrent unit required to construct a word. Here you can say why it is. So these are just maybe our question, not answer. These are just question. Does the pattern imply some kind of cognitive process, which mainly reflect the human's behavior, or as kind of whether any human's preferences leading to these kind of common uses, or some kind of phonotactic constraint is working on here. Like we know that okay, XY is very common, YX is not. Is there any phonotactic, okay, some kind of naturally it's working on that. Or some kind of, it's called limitation of our vocal anatomy. Because even we know that, okay, yesterday I was saying that, okay, once we start while we are starting any sound or word, we are using all possible spectrum. But once we start, we are further restricted. So whether that vocal anatomy is playing any role. So that's why, okay, we cannot utter too many variable. That's why we just, each word is ending with some just a small pattern. Something, finish, again word, again word, again word. So these are the common question we can say. So, yeah, thank you. Yeah, sure. Oh, which one? Huh. Yeah. What we, yeah, so what we did, exactly. So if you have Unicode, see, I didn't, why I have restricted only, I think if you will see my database, around maximum 25 things I have, 25 languages I tried. The only, yeah, here is it, right? Is I have split it into, each letter is my one unit. Here, each unit is my, each letter. Ka, kha, ga is a, e, u. Yes, sir.
We can do this.
The first letter is divided into two parts based on the consonant and the inherent vowel ra, u. Then the third one is ra, a, so re, and then kha, a, kha. What about the second letter, pa? There is an inherent a there which is missing from the structure, right?
No. See, it is okay.
How
Okay.
Yes.
Okay. So if you no. Okay. So machine is not doing anything here. So here. Okay. The good thing is I'm not using anything. For me, whenever I'm writing, let's say I'm writing development, I'm not writing development. I'm just writing D for 4 is D. Everything I've converted into a number. So okay. So when I'm saying Roop Rekha, oh, acha. you, yeah, okay, correct. Okay, correct. So, no, see, if you will give to a computer, computer will split into this way. You can just first, before giving this, you can just split it. Normal way. Either you manually split or your computer split. Computer will split into R, U as a separate. I can give you even, I can give you demo how we can. So, U and per. So now you can say that even in this inherent, that is anyway computer, if you will feed computer, that will work and that way. So the point is how you are feeding, what you are feeding, that is important. It is completely dependent on you. You can feed anything.
So for 10,000 words, doing it manually is quite difficult.
Yeah, obviously, that's why I haven't done anything. See, even from scratch, even scrapping, that's why I first talk I had given the scrapping. So don't do manual work. Just go. Okay, please, don't, is it recording? Okay, fine. Yeah.
Based on those two patterns of feeding.
Yes.
One carrying the inherent, the other one discarding.
Yeah, that is true.
These two ways of feeding will generate two different types of heights, not two different. Huh?
Yeah, see, that's true. So, okay.
And then the number changes. Here you have 1, 2, 3, 4. That will go up to 1, 2, 3 for Hindi.
No.
The
Okay.
highest is 3.
I'll tell you. It's not. There is a consistency here because if you will see, mostly the way people have developed. So the way people have developed the Unicode is like. So here it is. I'll tell. Consistency is all ka. The consonant, the ka, is a single unit. It's not splitting ka and a. Ka and a inherent. Inherent one is not. It's identified as a single unit, one. Here, when you're saying the ka, this roop, so I should not. So actually, this is ra and u, separate u, right? Actually, what is this? This is ra and u. Yeah. So this particular thing is separately saying that u.
Yes.
Yeah. So that's what the concept. So this is anyway we are not doing manual way. So that is you can do anything. See, I managed to get only 25 things. So I am happy. Anybody can. So I'm giving the method. Please apply. Okay. Yeah. So yeah. So what?
Hello.
Okay.
So, continuing with the same question,
Yep.
if we have ka and the halant matra or any other consonant with a halant matra, the computer will take it as two distinct characters, right? But phonetically it is just one, right?
Computer is not going to understand anything. What they will understand, see, pakka, yeah, it's not going to understand. See, they will understand with the simple thing. Whatever, because you will give database, right?
Yes.
You will give list of dictionary, right?
Yes.
Let's say, can you please come? That will be great. Then I'll work on your, anyways, just demo session. So I'll, just 5 words, whatever the way you thinking, it should be, can you just write it? Just 5 words. Just any language, whatever it is, just little bigger in size, bigger. Yeah. Little more bigger, yeah. Vimal. Anand. Let's say that's okay. Okay, no problem. How will you split? Because whatever way you want to feed, you can feed, right? So how do you want to split it? See, there is one. Oh yeah, just. If anybody is not agree with his splitting method, please come and do. Perfect. Yeah. Yeah, next one. Then I will work on this. And This should not be, right? No. See, this one, then you can. Oh, it's a full vowel? Okay, fine. Oh, whatever it is. Sorry. Then I'm bad. Now you understood how, even I'm being a Hindi speaker, I'm not doing. Okay, on my request, can you, Anand, any similar word, so that there will be some matching frequency? Other to which one? Either this one, see, Mal, Kamal, Kamal, easy. Okay, so what he has given, so what he has given, this one. Computer is going to understand this, right? So what is your target? Let's say you want to, which one? Let's say first one, you want to segment it, okay? What is the first step what I mentioned? The first thing is I said, let's say how many possible bigram you have. So K and 1 is 1. And ma halant, whatever it is. Then this one. So 1, 2, 3, 4, 5. 5 background. So what I have. Yeah, I'll come at. Yeah. So total 5. 1, 2, 3, 4, 5. So since it is 1 has common, you will just repeat it, right? Just you will cut 4 times. Right. Your time, you can save your time. So the question what you will put, probability of K-halant, comma, which anyway computer is not, in computer you will just write, assign 1, 2, 3, 4, 5, 6, anyone? Yes. So this, what is the probability? What I will do, I will calculate what is the empirical frequency here. Can you just, can anybody tell me what is the empirical frequency here? I think 1. Yeah, only 1, right? What I need? Empirical frequency first. Let's say, empirical frequency 1. I will just shuffle this whole thing 100 times, 1000 times. I'll get something, some value. I'll get the average value of it. Let's say the mean value of this particular, K-halant and you are getting something, let's say 5 something. I just randomly said, right? That's what you matter. You are not, because computer is not going to calculate inside anything else. Because you had already given your splitting. Now, on top of it, if you think that, okay, no, this is not correct, my computer should understand this way.
Yes. Understood.
My computer should read Kamal is like this. Ka, ma, la, first one is anyway thi. Vimal, I'll say, this is 1 unit.
Yes. That I understood. Yes.
Then this is,
okay.
So that is not going to affect your method. Method is completely robust. So whatever you input, whether it's a alphabet, whether it's a conjunct, or whole thing, or you can apply this method into sentence also.
Right.
Word is your unit,
right,
and sentence is your that.
Yes. Then the second question is,
Yep.
I'm doing this with
Sure,
all
please.
these
Thank you
scripts.
very much. Yeah. Oh, sure. Sorry.
I'm doing this with all the scripts and languages for which I know the graphical and phonetic value. When it comes to Indus, how do I decide that this specific graph stands for one phoneme, or this specific graph is composed of two phonemes, of which one is blah blah blah, other one is blah blah blah. I'm not talking about alphabet, I mean vowel consonant.
Yeah.
Unless I know those individual values, how do I generate the subsequences, subsets?
Okay. The start was from where I did start. I started to answer the question whether my language, sorry, my string has any syntactic structure. Why? What I was saying the syntactic structure? My meaning of syntactic structure was recursive structure. Recursive meaning that repetitive, motif, right? I was looking for that one. That is giving me that motif. And that motif is not telling me anything about whether what is the phonetic value of it. My target is done. Yeah, there, okay, even there, if you can think, okay, whether motif will differ in different contexts. I said, if you will purely consider your text, if you will give into pure alphabetic system, even that time it will give you motif. But in terms of alphabetic system, if you will convert into alpha syllabic style, even you will get the same answer. Even if you will use the whole sentence, you will get the same answer. So interpretation is not you will get it. Simply it's saying you whatever you have given, there is repetitive structure or not. Yeah.
And your conclusion is it's repetitive, recursive.
It has recursive structure similar to what language is, other language is showing on. Yeah. So one is that. Another is this method is very robust enough to work to apply anywhere. The next interpretation is found that okay, these whatever motif based on given situation, these motif irrespective. Okay, when I'm saying just accept the Indus, these motif are showing the Zipf's law, and this is much more fundamental part because Zipf's it is showing that okay, it has some a specific pattern is uses probability of uses. So word in word construction, and even the number of units you are using construction the process is a very much constant in different irrespective of what language you are using. Possibly what is happening, see the writing system, what all the time people talk, the writing system, many times it's happened that one language was using one writing system and over the time it's shifted into another writing system. So based on whether your Persian is writing using cuneiform or Persian is writing by Arabic system, the length of your text, the length of your string will vary. But what is constant? Your language, right? That is somewhat is catching here. Doesn't matter whether using cuneiform to represent Persian or Arabic to Persian. It catching your essence, the fundamental essence. That's why I'm saying this is the fundamental part. Yeah. So yeah. So yep. Yep.
No, if I have a dictionary of words, can I get
It's a simple way that in Python there are even simple you can use split function. There are many methods so you can do that. So it's just a matter of the language you are using. What language?
into the aksharas, the alpha syllabic components?
Sorry?
Into the aksharas, the alpha, like you said here, right?
Yeah.
I think you have key as one that way. Is it possible to split it that way?
This way or that way?
No, the last one here. You said Vimal, right? In the V is 1, Ma is 1.
So what you can do, see, is a little typical, see, splitting this way is very easy. You can use, yeah, that's what I'm saying. So this is very easy. If you use split function of Python, it can give you this. Since you know that how many of this R, you can keep into one variable, and wherever it is conjunct, you can just club it by join function. So then you will get the ultimate result. It's just a matter of the language, how programming language you are using.
When we encode an Abugida font, normally let's say Va and E, that as in Vimal, okay, Va and E, the combination is E. So we always define the sum and provide a script for the ligature. So you can either take it as a sum or you can take it as two individual components. If that answers your question. Yeah.
Yeah,
so that is
for this particular work,
essentially encoded like that.
For particular work is, that part comes before this whole thing. Input is whatever you want to decide, whether this way, that way, you can decide. Even you can split into a further point. You can just decide it. Yeah, so the point is, you can, okay, we almost, so maybe I'll just show a few small things. Because, okay, I was thinking that I'll just do, yeah, so it is. Yeah, so what if anybody want to work on it? So either you can download any data of your own interest, or if you want, you can just type this tinyurl.com bits and script, and then you'll get what I have just listed, one data source, just the list of English words, which I have taken from. Actually, this particular, the Meisner's, the Google Ngram. This has very fantastic Google Ngram data. So this you can go. They have the whole statistics. Okay, that is anyway, it's not part of this. So I'm just saying that, okay, you can just go and click here. You will get whole text. I just copied few, top few, just for quick work. If you want, you can just do that. Otherwise, since it's a very small time, very less time left, we can just quickly go through how it's working. So once you, let's say okay, these are just basic Python libraries. And then this is my data what I have kept it. You can just run it. So if I can show you how the exact data is. So this is the word list, what I, yeah, you can say this kind of word list is available. So once I have this, okay, so you can, what is your target? Let's say we want to segment the word development. Okay, so how I can do that? First, I'll just, same way, I'll calculate the empirical bigram frequency. Then I shuffle the whole database into maybe, in this case, what I have defined as, how many times? 1,000, I think 1,000 times. Yeah. So, and then you can just, let's say, just run it. So first, I'm splitting it. So I'm calculating the total number of bigram, how many bigram I have, what's the z-score of corresponding it, and then just merging it. This particular function is just doing the replacement while I was just doing that x1, x2, and then replacement with the meta character. So what I just the, oops. Oh, achha. So what is the problem here? Can anybody who, function was not called, so I do all these things. Yeah. So function is written here. So now it is started the whole things. So if you will see how it's splitting, maybe anybody, someone can help me. I can't see. Can you please tell me how it has been splitted? So my target sequence was, please tell me, what is that? Okay, so what first, in the first case, it is saying the highest frequency, highest Z score, only is giving the highest one, rest are just ignoring it. It's saying that the highest one is the VE. So now, so wherever is VE, just split it. It's saying this one. So what next it's merging? Can you just please help me? NT. So then NT, after that? Sorry? ENT, okay. Oh, acha, this one. EX2, okay, three. Then EX2 is that. Then EX2 after that? MX3. So, okay, next. DE, okay, sorry. X4, X5, okay, Then LO, X6. Then X? Oh, X1 and LO. Sorry, LO, okay. Okay. Acha, okay, okay, fine. Okay. 7. Then DE, DELO, okay. X1, X6, oh, acha. Okay. Then X7P, where is that? Okay, here. Next. 5 and 8, okay. Okay, pretty good. Sorry, 9. Okay, next is finished anyway. The next is by default this one. So yeah, it's good. It's a development, right? So it's at least it looks quite good. Any word you want to suggest? We can do work on that. Let's say how it will, if I'll do bits and script. I don't know whether it work. It's a multiple word. It's a sentence. It should give, right? I'll be trouble and okay if it's not bits. Should I give? Okay. Bits and scripts, right? But here I'm doing little things. Don't expect too much, but maybe okay. Since if you'll give enough data, it should work very well. Otherwise, what I have done, I've taken a sentence and then I expecting it should bits and script at least this and should come at least. Okay, let's see. Okay, with little hope, let's run bits and oh, acha, sorry. Okay, so here the problem. How I want, I have just given the boundary. So okay, this will trick. This is okay, completely on your choice how you want to give the feed. So bits and scripts, let's say run it. Okay, AN. Let it run. How many times? at least, okay, just, I'm just stopping it. I'm going to do 1,000 trials so that it will be. Okay. Okay, meanwhile, I'll just write it down. So we should expect at least okay. So can you help me, please? Hope by now it has come. Okay. What is the first one? ND. Okay. Then? RI. Where is RI? Acha, RI. X2 RI. Okay. Acha, oh, acha, fantastic. Okay. I was not expecting that much. Sorry? BI, okay. X4. Oh, oh wow, bit. Good. Computer, understood computer, okay. Fantastic. X4T. X3S. Oh, acha, completed. That's good. Okay. That's good. I was not okay. CX2. X7 and P or B? Okay. X8. Oh wow. Okay. S and S6. Oh. S and S6. No, it's not possible. No? S6 is here. So, why? Wait a minute. Where is S6? Whether I now give wrong number. 1, 2, 3. Can you S6 X1, X2, X3, X4, 5, 6, 7, 8, 9. Okay. Okay, can you just tell me whether ND is X1? Yeah. Okay, that's why maybe I did the wrong naming. That's why it's coming. ND is X1. RI is X2. X2 is RI, correct? And then AX1 is X3 is AX1, correct? That one is up to BI is X4. BI X4, correct? And X4T is Okay. Okay, x4t is x5.
X6 is A and DS.
6 is x3.
A and DS is X6.
Ah, that's why, no? That's okay. We did. That's what it is. We can do mistakes, right? Computer normally not. S6. Okay, next. So yes. So this is X6, right?
So A and D is X3, then A and DS is X6.
This one is what?
So you have to draw A and D first,
A and D.
naming it X3. X3.
I'm really
So
confused.
first join A with ND.
Can anybody come and help me? Yeah. Okay. Done?
Yes.
Okay, so then after that, CX2 no, please. Then let do it again. See, no, there is no CX2, right? C is here only. Can we do it again? It will unnecessary confusion. Yeah, somebody can help, come and help me. What is the X1? Yeah, sure, please. I'll tell you, just write it. Okay. ND is X1, and then RI X2, and then AX1 is X3, okay. BI is X4, okay. BI X4, X4T is X5, no, don't write before I say, otherwise it whole, see, X4 and T, X5, X3 and S6, C and X2, yeah, X7P, P, please, yeah, X8, then X8T, correct, and then S6, yeah, bits, yep, yeah, correct, and then X5, X10, this one, bits and yeah, and then fine, done, yeah, that's good, yeah, then that is any, yeah, that's natural, yeah. So, yeah, so now, yeah, bits and script. The point is, now what you can do, you can say that, okay, don't, if you have come up to here, so now what you can do, you can say that it's not natural division. What you can do, you can just go through the z-score of this particular things. Wherever you find that, okay, something is less than whatever the threshold you are saying, and then that is the significant part, and it's managed. Yep. So in this case, if you want, what is the last one? Like last, say this one, 1.4. After the, before it, all are, yeah. Before, okay, all tops are, we're saying that not exactly, but these are right. And if you will increase your database, since just for test I used small data sets, it's managed pretty well. Yeah, this is what it is. If you want any sentence you want to give, you want to test, you can just tell me. Maybe give a small sentence so that will save time. Yeah, so almost done. So if I have any question, please. Otherwise we can stop. Yeah, any question? No? Okay. So yeah, so we can stop here. So in that case, if there is no further question. Yeah, I'll share the one. So the whatever the later we'll share everything. Yeah, web page will be there. Yeah. Thank you.